Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our student course registration system demo, and specifically what we're going to do is we're going to focus now on the ability to export students. This video is part of a larger series of videos that focuses on our student course registration system demo. And specifically in this series, we're going to focus in on the use of static arrays to be able to import information from a file, manipulate it, and then potentially write it to a file or display it to the console. This video assumes that you've watched the earlier videos on the setup of the project as well as how to utilize your StaticArray.h. I would encourage you to go ahead and open up your copies of your scrs.h as well as your staticArray.h and your core.h and your students.csv. So let's go ahead and get started. In this video, as I said, we're going to focus in on our export students. In earlier videos, we have imported our students and we have displayed our students. Now what we'd like to do is figure out how can we write our student array to a file. And so to begin with, we want to take a quick look at our function signature, and you'll see that it accepts a file name as a constant string, a array of students as a constant array, and the integer count, which simply keeps track of how many valid students there are in the array. So essentially that count is going to tell us how many students we want to write out to the file. At this point, go ahead and take a look at your students.csv. Remember, for instance, the order in which the columns are. In this case, it's a status for the first column, a ID for the second column, first name, middle initial, and then last name. And so, for instance, in your export students, you may decide that you want to keep the same format or perhaps change the order up in your fields. For this example, we're simply going to keep the exact same order. So essentially, this export students is going to export a file perhaps after we have added a student or changed the order of the students in the file. So to begin with, what we want to do is we want to take a look, refresh our memory at our import students. And specifically what we want to do is look at some of the logic that we used to address the file name before just blindly accepting that we have a file name to be able to write to. And you'll notice here that what I've done is I've simply checked to see if our file name is null, the string length of our file name was less than 5, and then also that it included a .csv file extension. Now, where did we get the 5 characters from? Well, that's just simply the shortest file name that could include the .csv file extension. So this would probably be a really good start for us in our export students as well. So I encourage you to go ahead and just simply make a copy of it, and then we can utilize it in our export students. Now, we're also going to need some additional temporary variables, not the least of which is going to be a way of opening our file, and that is going to be a file output pointer. We also are going to need some temporary variables that will facilitate our string find, particularly our locations. And our locations is going to be a integer array. And basically what we want to do is simply make sure that we don't accidentally have more locations in our file name than what we are capable of handling that match the .csv file extension. Now, basically what would happen here is if your user accidentally, for instance, had sample.csv.csv, you wouldn't want to only have one value in your locations array. However, you would not expect the user to pass a file name with .csv repeated multiple times. So at some point then you basically can only handle so many scenarios. And so what I'd like to do here is simply have a variable called locations, and we're going to assume that if we've got anything more than one .csv file extension in our file name, then we've got a greater problem on our hands. At this point, then we would expect a seg fault or some sort of unpredictable behavior. But at this point, what we can do is just simply provide then a warning back to user or even an error that says invalid file name provided. And we want to simply set our results equal to exit failure. Now, for the next variable, we can get our inspiration once again from our import students. And in our import students, you'll notice that we check to make sure that the students were in fact not equal to null by virtue of checking to see if it was equal to null. And if it was equal to null, once again, we simply printed an error message and we changed our results to exit failure. So we can once again simply borrow this code from our import function and utilize it then in our export function. Now, if we've assumed we've made it this far, then we can continue with actually opening the file. So under the else branch here, what we'll do is we'll say output is equal to fopen, and we want to open whatever file name was passed, and we want to open it for writing. Now, once again, you can consider whether or not you would want to open it for appending, depending on what the purpose of your application is. In this case, we're just going to simply overwrite whatever file exists there. We're not creating a log file. In other words, we're not appending. But then what you want to do is you want to check to make sure that your output file pointer is in fact not equal to null. And if it is, basically we have a problem here. In this case, we're going to print F error failed to open. And we can go ahead and provide a %s, which will allow for us then as a placeholder to tell the user which file we were unsuccessful at opening. This may, for instance, flag the user that maybe they have the file open in Excel, or maybe they don't have write permissions to a particular folder. But either way, we want to then have our results be equal to exit failure. Now, under the true branch of our if statement, basically at this point, we want to go ahead and make sure to close the file before we forget. And then before closing it, of course, we want to then write to the file in the order that we want the columns to be from each one of our students. So remember we said that it's the status, the ID, the first name, middle initial, and then last name. And there's a couple of ways you can do this. You can have multiple fprintf statements, or you can simply then have one fprintf statement and then have it span multiple lines. So that I don't wind up with a ridiculously long line of code, I'm going to go ahead and have it span multiple lines. And I'm just going to simply use a single fprintf. I'm going to use our output file pointer. And I want to think now about the format spec and specifically each one of the data types associated with my fields. So my enum will be a %d, my ID will be a %s, my first name will be a %s, my middle initial will be a %s, and my last name will be a %s followed by a new line. Keep in mind with fprintf, if you want to see it in the file, you have to explicitly state it. That includes the delimiter as well as our new line character. At this point, then, we simply are selective about the properties or the values that we want to put in those placeholders. And I'll do these on individual lines so that you can see it more clearly. But basically, we're going to use the students array. And what we want to do now is we want to set up a for loop that would leverage our index variable, much like we did in our display all. And we're simply going to display each one of the fields. So we'll start with our student status, our first name, or rather our ID, our first name, our middle initial, and then our last name. At this point, you'll notice that we don't have our index variable, and we also haven't set up our for loop. So we simply wrap this entire fprintf in a for loop that starts out with our index equal to 0, index less than count, and then index plus plus. The only thing left to do now is to declare our index variable. And at this point, we should be back to working code. We have a semicolon here that we have to include after our fprintf. And so if we go ahead and build it, we have, once again, working code. And now what we need to do is figure out how to drive that in our driver. And once again, you can go ahead, much like we did with our examine students, and create another switch to test this, or you can simply just leverage one of our other switches. And for instance, in our display all, we could also turn around and export our students after we imported them. However, this is probably not a great idea because it would be unexpected behavior to export every time you simply wanted to display all of your students. So once again, for testing purposes, you may simply include in here in your display all results equal to, and then export students. And in this case, what we're going to do is we're going to create a students underscore new dot CSV. We want to pass to it the students array and the count. And as I said, alternatively, what you could do is you could create another branch of your if statement to be able to handle demoing your display, or excuse me, your export function. At this point, we're just going to leverage our display all, we'll build it, and then we're going to test our display all function once again. You'll see that nothing changed on the command line from our earlier example. However, the big difference is that if you were to go into your distribution, into your debug, and into your MinGW folder, you should now see a students underscore new dot CSV, which you can then drag and drop into NetBeans, and it should look exactly like our students dot CSV. Basically, you can think of your export function as working very similar to your display students and display student functions, but the big difference is that instead of displaying the console, it's writing to a file. So once again, hopefully you found this video useful. I would encourage you at least before you get done testing this to go ahead and comment out your export students, or at least put it somewhere that makes a little more sense rather than leaving it in display all. But if you have any questions, comments, or concerns, don't hesitate to email me, and thank you for watching.